completely forgot to post the grades on Blackboard, so. Sorry, usually I do, like usually is, what I do is I sit next to my computer and all that, but, I didn't.
Well, you got them on before class.
Yeah.
You hate beer that night.
Shh. I was doing it at the same time. Optimizing my time.
Does the drinking affect your grading?
Only in a good way. I usually get nicer the more I drink.
Hey, are you buying us beer or something in the class?
Sure.
Okay, thank you. After this hard work.
I mean, it couldn't hurt.
Apparently, it's not bad.
That's
Did you get 100?
I'm expecting
the cheap stuff.
It works just as good as the expensive stuff. I don't care.
Today on 16.
No, the only thing I didn't feel really good about was the one that we were talking about with like the Boolean algebra. Yeah, I felt pretty good about it. I was like, well, and there were only 2 point questions, maybe. But I didn't bomb any of the questions.
Right.
This is just the one.
Well, the 2 point
Thank you.
you pretty much all right there. Get one.
Yes, sir.
Did you take the exam today?
Yeah.
Or are you going to take a different class?
So that's kind of.
That's okay. I just didn't know because I don't know if I need to return. So you have to take. Okay, that's all right. Not a big deal. I just needed to know. You're good.
So it's the final take home?
No. You're right. Come on, Chris. I mean, I could make it take home, but I could make it much more difficult than
Well, you could, but you could make it take home and not make it any more difficult.
See, what I was thinking is just make it take home and make it ridiculously impossible. So that way when I grade it, it's just an easy to put a 0 on it for everything.
You should make it really, really difficult and make it 100% from 0 to 10 points. And anything above that.
I kind of like the idea of just giving it to you guys in class.
Just give us all hundreds and we can call it a day.
Oh boy. There seems to be something very ethically and fundamentally wrong with that.
There's a lot.
Definitely a lot wrong with that. I wouldn't feel right doing that. I mean, I think of all the classes I just suffered through. None of my teachers ever gave me a break.
What about the ones you studied 20s to?
I didn't know. Professors don't take 20s. You can't label more than that.
Yeah.
But you don't take 20.
I take 5s.
See, when I had King for Calc 2, I actually had a D in the class, but she bumped it up to a B.
How?
That's
I have her right now.
Yeah,
For Calc 2?
Yeah, work really, really hard.
You ever heard of a guy called George Dantzig? You never heard of him?
I'm actually doing
So he's a very famous mathematician. So he was doing his PhD, so he came to a class. So the professor wrote something on the exam. So the class, he missed the class. So it was supposed to be his final. So there were three problems. So the professor asked them to do 2, but he did not, since he was not in the class, so he took all 3 problems. So he did the 2 problems really good. The 3rd problem was known to be the most unsolvable problem in mathematics. It took him a very long time and he solved it. And he gave it to his professor. His professor was so surprised that he gave him a PhD for that.
Nice.
Look at it, George Dantzig. So maybe this take home could be like that.
Maybe. Probably not.
We get an answer, we get a PhD.
Not from here. I could not grant that. Okay, guys. So I guess what we'll do today is we'll start recursion and then we'll finish it up next time. You guys may or may not have checked this, but on Blackboard I posted the next Monday I canceled class because of the Thanksgiving holiday. So if you show up here next Monday, good for you. You'll come to an empty classroom, or whoever else decided not to check Blackboard. Okay, so if you want to, we can hold class. I don't mind.
Is it Monday or Wednesday? Wednesday we are off. Monday also?
Wednesday we're already off, but Monday I canceled class.
Oh, okay, so we are off the whole week.
Is that a problem? I mean, we can
No.
definitely show up.
That's what's not gonna hurt us.
Oh, I'm
That's the
sorry.
only class I'm on.
How many more sections do we actually have?
Two.
Two?
Yeah. So I've already checked the schedule, we're good. I wouldn't cancel class if we didn't have the time.
Right, yeah, as long as it's not gonna hurt us.
It's not gonna hurt you guys. I
Are
wouldn't-
we ahead anyway? Oh, no, no, never mind.
We're on
Push back
pace,
the-
we are good, so trust me, I wouldn't put you guys in a disposition where we're rushing, okay? Alright, so any other questions about canceling class? I didn't think it was a big deal, I didn't think it warranted a 2-minute discussion, but, okay. Alright, so basically guys, when we talk about recurrence relations or recursion, we're basically saying that each iteration thereafter of the sequence is predicated upon the previous one, okay? So, and essentially we need some initial condition to be able to generate or spawn new iterations in the recurrence relation, okay? For you guys that ever programmed recursion, recursion is a very expensive way to generate iterations, okay? In fact, if you run 100 of them, it can be very costly very quickly. So what we're going to learn is that there are ways to take something that's recursive and write it into something that's just non-recursive, and then you can access the index very easily, okay? That's actually one of the most important things that a computer scientist could ever do, is to get something out of recursive and write it into something that's just linear, and you get the output directly from the input. All right. So one of the first things that we have to do is, if I give you guys some sort of recurrence relation, just be able to write out the iterations of that. Okay? So let's say we have this recurrence relation, a sub n is equal to 3a sub n minus 1 minus 2. And I give you that the initial condition is that a sub 0 is equal to 2. And I ask you guys to list out the first 6 terms of the sequence, okay? The first term's got to be really easy. What's the first term in the sequence?
2.
Yeah, because it's given to you, right guys? So you can't get that one wrong. Well, you could, but that'd be embarrassing. All right? To get the next iteration of the sequence, all you do is you substitute 2 back in for a sub n minus 1. So a sub 1 is going to be equal to 3 times 2 minus 2, which is equal to 4. Okay. Does that make sense to everybody, guys? You just plug in the previous iteration to be able to generate the next iteration. Now, if someone, it's okay. If anybody else comes in, just make sure they get one of these for me, please. Thank you, sir. Appreciate it. To be able to generate the next iteration, which we'll call a sub 2. That would be 3 times 4 minus 2. Otherwise known as 10. Okay? And then we just keep going on thereafter for the other 3 times. So a sub 3, 3 times 10 minus 2, that's going to be equal to 28. A sub 4, 3 times 28 minus 2, that's going to be 82. And then finally, the 6th element, 3 times 82 minus 2, that's going to end up being 244. Okay? So that's what a recurrence relation is, guys. I mean, it can't get much easier than that, right? Input, output. Okay? Now, unfortunately, okay, to get to this element, obviously it took a little while to be able to take something like this and to get to that 6th element, okay? Imagine if we were doing that by hand and I asked you guys for the 100th element, okay? We'd be here for a long time writing out each of these iterations, okay? By next time, okay, we might not get to it today, but next time, we can actually take this sequence right here with this initial condition and we can write it so that it's non-recursive, so that it's explicit. Remember we talked about explicit and implicit, and this is recursive. We can write it into the explicit form where we can just stick a number in it right away. Okay, that's what we're ultimately trying to get to. Okay, makes sense, guys? Okay, we could even have these sorts of sequences with more than one recursive term in it. Okay, so we have this recursive sequence b sub k is equal to 2, b sub k minus 2, plus b sub k minus 1. And again, I asked you guys for the first 6 terms of the sequence. The first 2 terms gotta be easy. That would be 2 and negative 2. So b sub 0 is equal to 2. B sub 1 is negative 2. Okay. If I wanted to figure out what b sub 2 was, okay, can somebody substitute and tell me what b sub 2 would look like without giving me what the answer is? But what do I substitute
So
where?
2 times negative 2,
So 2 times,
negative 2.
not negative 2, times 2, right?
Oh,
Because
you have to
wanna
do
go-
with
if
the
you
initial
notice, it's k minus 2. That means 2 iterations
Oh, okay.
ago. Okay? So 2 iterations before this one would be positive 2.
Okay.
And that would be plus negative 2.
Two.
Okay, does that make sense, Art? Okay.
Gotcha.
This, guys, the k minus 2 means 2 iterations previous. K minus 1 means 1 iteration previous. That's probably the easiest way to think about it, okay? This will just work out to be a regular old 2. And then we can go ahead and just substitute again, okay? So for b sub 3, or you want to redeem yourself, sir, and tell me what this one looks like?
B sub 3 should be 2 times negative 2 plus 2.
Yes, sir. Which is equal to negative 2. Okay. If we were to compute b sub 4, b sub 4 is going to be equal to what, guys? 2 times 2 plus negative 2, otherwise known as 2. And then, as you guys can see from the pattern that's going on here, you guys can probably guess that b sub 5 is negative 2, but let's just verify that b sub 5 is going to be 2 times negative 2 plus 2, which is indeed negative 2.
Oh, so this is what I call harmonic or something like that?
Not harmonic, good try, all right? It's actually something called an oscillating
Oscillating,
sequence.
that's right.
Not alternating, but it is alternating, but it's also oscillating between 2 values, okay? So, by the way, guys, both of these are divergent sequences, right? Meaning that they never really reach a specific value. Okay, question, gentlemen? You sure?
They're retired, yeah, no.
Okay,
We're good.
yeah, just don't talk when I'm talking, we'll be good. All right, other questions, guys, I can answer? Okay, so these are our first 2 instances of being able to work with recursive sequences. Pretty easy, right, guys? We can all do this, okay? One of the things eventually we're going to do is we're going to be able to get to a recursive sequence and be able to verify that they do satisfy. So that, I think that's the next thing that we should do, is that if I give you guys something that's an explicit sequence, I want you guys to be able to show me that it satisfies the recursive sequence. Okay? Now, eventually, what we're going to be able to do is we're going to be able to get to this. Okay? But for right now, we can only verify it. Okay? It's sort of like when you guys learned basic algebra. One of the first things you guys learned was plug the number in and verify that it satisfies. All right? This one, where I'm giving you guys the answer, we're just verifying it. Okay? So I give you guys that the answer, or the sequence, is a sub n is equal to 3n plus 1. And I'm giving you guys that the relation that is in question is going to be a sub k is equal to a sub k minus 1 plus 3. Okay. So, this is really the answer to the question that eventually we're going to be asking. Okay? Our job is to verify the answer. So here's how we're
So
going to do
the
this.
answer is the relation?
What's that?
Which one is the answer? The relation?
The sequence is the answer.
The sequence
okay?
is the-
Because that's non-recursive. Okay?
Okay.
We want something that's not recursive when we can. So what we're basically saying is that these 2 are the same thing. Okay? They'll produce the same terms. This one's much easier though. Like for instance, if I wanted the 25th term of this guy, I would have to do 25 iterations. If I want the 25th term of this, I just stick 25 in for n. Okay? So this one's much less costly. Okay, so here's how we're going to verify this. All I'm going to do is I'm going to substitute a k in for the n over here. So a sub k is equal to 3k plus 1. Okay? So all I'm doing is I'm just taking whatever the subscript is, and I'm substituting it back in for k. Okay? That's going to be equal to, instead of n, I'm going to plug in a k plus 1. So this is 3 quantity k plus 1. Plus 1, okay, and then, is that a plus 3? Yeah, plus 3 over there. Oh, I have a feeling it probably should have been minus 3. Let's do this. Let's change this to minus 3, just to make it work. Sorry about that. So, on your guys, on the sheet, just change this plus to a minus. Just so we can make it work, so I can show you. Okay, so I probably made a typo when I was developing this. Okay. If you guys will notice, you can distribute and collect on the right-hand side. So you guys would get 3k plus 1 equals 3k plus 3 plus 1 minus 3. Or in other words, 3k plus 1 equals 3k plus 1. Okay. and that verifies that that sequence satisfies that relation, okay? And again, guys, it's much easier to work with this animal, which is just a linear sort of sequence, as opposed to this recursive sequence, okay? So, does that make sense, guys? All you're doing is you're just plugging in a subscript back in for the end. That's all you're doing, and then you're doing some algebra, okay?
Yeah, that's where at the very beginning I
Okay.
didn't follow.
So all I did, see this k minus 1?
Yes.
Oh, that's what I did. I'm sorry, guys. All right, so let's do this over. Just erase everything that we just did.
It would be plus 3 then, wouldn't it?
Right, it would be plus 3. So I had it right the first time. So I'm just telling everybody to erase everything. Okay, it actually does work as it was. So this was plus 3. Okay, sorry about that. The left-hand side was fine. So all we're going to do is we're going to substitute k back in for n. So that's 3k plus
So
1.
you're making the a sub k equal to the right side of the sequence, except with a k instead of the n.
Correct, right. Because all we're doing is we're saying if this is a sub n, whatever n is, you just plug in here. It's just like a function, okay? Like a one-to-one correspondence. If this was pi, this would be 3 pi plus 1. So over here, since this is a sub k minus 1, this would be 3 quantity k minus 1, okay, plus 1, okay? So that's the sequence with k minus 1 in there, okay? So sorry about that. I thought for some reason it was plus 1 when I did it initially, okay? And then we still have the plus 3 that we're bringing down. Okay. So what I have in brackets, this is a sub k minus 1. This would be the previous term, okay? And this would be the next term, if you would. You guys can clearly see if we distribute and collect, the 3's would cancel out. We'd be left with 3k plus 1, which is what it should have been the first time. So this is 3k minus 3 plus 1 plus 3. 3's cancel out. 3k plus 1 equals 3k plus 1. Okay.
Alright, so whatever it's in, we just substitute as k.
That's all it is. It's